Stand at the edge of a modern industrial cornfield in Iowa or a vast soybean expanse in Brazil, and what do you see? You see a triumph of geometry, endless, parallel lines stretching to the horizon, a vibrant, uniform green that screams efficiency. But look closer, step into the rows, listen. The silence is deafening. There is no buzz of insects, no rustle of small mammals, no chaotic hum of life. You are standing in a green desert, a biological vacuum artificially sustained on life support. This visual perfection is actually a state of extreme fragility, a ticking time bomb where a single pest species, finding an endless buffet of its favorite host with zero predators to stop it, can trigger a famine-level event in days. This is the paradox of modern agriculture. We have engineered systems so efficient at producing calories that they are terrified of nature itself. To keep this fragile illusion alive, the industrial complex has sold you a subscription model of chemical warfare, pesticides, herbicides, and synthetic fertilizers, designed to kill the very biology that used to do the work for free. But there is a glitch in their matrix, a ghost in the machine that they have spent billions to drown out. It is not a new chemical or a genetically modified superseed. It is a relationship. It is a specific, forbidden plant combination, a biological key that, when inserted into the soil lattice, disrupts the pest's radar, electrostimulates the nutrient exchange, and renders the chemical arsenal obsolete. This isn't gardening. This is insurgent engineering. And to understand why this simple technology was buried, we have to go back to the moment science took a wrong turn, trading the wisdom of the forest for the arrogance of the factory. History is often presented as a linear march toward progress, but in the realm of agriculture, it was a calculated erasure. To find the blueprint we are looking for, we must dial back the clock to 1937, to the dusty laboratory of Austrian plant physiologist Hans Molisch. It was Molisch who first codified the term allelopathy, derived from the Greek allelon, of each other, and pathos, suffering. He wasn't studying companion planting as a quaint folkloric tradition. He was documenting a sophisticated form of biological warfare. Molisch demonstrated that plants are not passive green sculptures waiting to be eaten. They are active combatants using complex biochemistry to secure their territory. He proved that certain species release specific chemical agents into the soil and air, inhibitors to suppress competitors, and signals to warn allies. This was the dawn of a new agricultural physics, one that treated the field not as a factory floor, but as a responsive, communicative network. However, just as this invisible science was gaining traction, the world exploded into war. The global conflict shifted the industrial focus entirely toward the mass production of nitrates for explosives and nerve agents for chemical warfare. When the smoke cleared in 1945, the vast industrial infrastructure built for death needed a new market to survive. They found it in your food supply. The Haber-Bosch process, which had synthesized ammonia for bombs, was retooled to flood farms with synthetic nitrogen. Why bother understanding the subtle, invisible voltage of root interactions or the delicate atmospheric signaling between a marigold and a tomato plant when you could simply carpet bomb the soil with NPK? The chemical giants launched a campaign to rebrand traditional biological knowledge as inefficient peasantry and synthetic dependency as modern liberation. This was the Great Divergence. The research into allelopathy, the study of how plants naturally protect each other, was defunded and pushed into the shadows of academic obscurity. It didn't fit the business model. You cannot patent the frequency at which a basil plant vibrates to repel a hornworm, nor can you sell a subscription to a root system's immune response. The industry chose to ignore the sophisticated, self-regulating mechanisms of nature in favor of a brute force approach that prioritized yield over resilience. We didn't just lose a technique. We lost a fundamental understanding of how the botanical world communicates. We traded the wisdom of the forest for the addiction of the laboratory, and in doing so, we silenced the very frequency that kept the pests at bay for millennia. Why does the modern agricultural machine insist on planting millions of identical clones of corn, wheat, or soy, knowing full well that this genetic uniformity invites catastrophe? The answer lies not in biology, but in the cold, hard calculus of the supply chain. Monoculture is the physical manifestation of economies of scale. To a machine, diversity is friction. A harvesting combine cannot navigate a chaotic web of beans, climbing cornstalks guarded by squash. It needs predictable, standardized rows. The industrial food system was not designed to maximize nutrition or ecological health. It was designed to maximize throughput and standardize processing. But there is a darker variable in this equation. Monoculture creates a mathematical necessity for external intervention. When you strip an ecosystem of its complexity, you remove the immune system. You create a biological vacuum. In a natural forest, a pest outbreak is self-limiting because the host plants are scattered and hidden among non-hosts. In a monoculture field, the host is everywhere. This vulnerability is not a bug in the system. For the agrochemical giants, it is the primary feature. A self-regulating ecosystem is a bad customer. It doesn't need synthetic nitrogen. It creates its own. It doesn't need patented pesticides. It deploys its own chemical defenses. Therefore, the one-plant combo isn't just a gardening technique. It is a wrench in the gears of a trillion-dollar revenue stream. If you plant a tomato alone, you are a customer for life. You will buy the fertilizer to feed it and the spray to protect it. But if you plant that tomato alongside its specific allelopathic partner, you break the cycle of dependency. You are no longer amortizing the cost of your food over a supply chain of chemicals. You are harvesting the dividends of natural physics. The industry fears this math because it subtracts them from the equation entirely. We are now entering the realm of the invisible, where the true battle for your garden is fought. Forget what you see. In the microscopic war zone of agriculture, vision is secondary. The primary guidance system for 90% of garden pests, from the cabbage moth to the whitefly, is olfactory. They do not see a tomato plant in the way you do. They scan for a specific chemical signature, a molecular beacon drifting in the wind. This is where the physics of our forgotten plant combination comes into play. It acts not as a shield, but as an active jammer, a biological electronic countermeasure (ECM) system that scrambles enemy radar. When a target plant, like a tomato, grows in isolation, it emits a distinct profile of volatile organic compounds, VOCs. A clear, unencrypted signal that screams food to any receiving antenna within a half-mile radius. However, when you interlock this plant with a specific guardian partner, most notably the genus Tagetes, marigold, specifically the wilder, non-hybridized varieties, you fundamentally alter the atmospheric chemistry of the immediate zone. The guardian does not just smell bad to the pest. It floods the local air column with a chaotic barrage of terpenes, limonene, and alpha-pinene. Think of this like a fighter jet deploying chaff to confuse a heat-seeking missile. The pest's antennae are receptors tuned to a specific frequency, the scent of the tomato. The guardian plant broadcasts a white noise of high-intensity VOCs that overlaps and masks the target frequency. This is called olfactory camouflage. The pest may physically fly right past your crop, unable to achieve a lock-on, because the chemical signal has been drowned out by the guardian's emissions. This is not magic. It is gas chromatography in real time. You are using the laws of diffusion and molecular density to hide your food in plain sight, rendering the Pests navigation system useless without spraying a single drop of poison. If the air is the battlefield for the radar war, the soil is where the trench warfare begins. While you are distracted by the leaves, the true silent killer of the garden, the root knot nematode, is moving through the subterranean matrix. These microscopic parasitic worms are heat-seeking missiles for your plant's root systems, navigating the darkness by tracking the electrical and chemical gradients of growing tips. In a standard monoculture, the soil offers zero resistance. It is an open highway for infection. But when you introduce our specific guardian genotype into the root zone, you are not just planting a flower, you are installing a subterranean high-voltage perimeter. The weapon here is a sulfur-containing compound called alpha-terphenyl. As the guardian plant grows, it pumps this phototoxic thiophene out through its root hairs and into the surrounding rhizosphere. This is where the physics gets fascinating. This compound is not merely a passive toxin, it acts as a molecular disruptor that targets the cellular integrity of the nematode. When a nematode enters this charged zone and contacts the compound, the alpha-terphenyl permeates its cuticle and infiltrates the lipid bilayer of its cell membranes. Think of the nematode's cell membrane as a biological battery, maintaining a precise difference in ionic charge, positive on the outside, negative on the inside, to function. The alpha-terphenyl acts like a short circuit. It compromises the membrane's insulation, causing an uncontrolled flood of singlet oxygen and reactive free radicals. This oxidative burst punctures the cellular wall, causing the organism to lose its ionic containment and essentially leak its vital energy into the soil. We are talking about the depolarization of the pest's biological electrical system. The result is a sterile zone, a no-go radius around your food crops, where the soil ecology has been weaponized against invaders. The nematode doesn't just decide to leave. Its internal physics make survival in that zone impossible. We have decoded the physics, but now we face the supply chain trap. If you walk into a standard garden center today and buy a tray of marigolds, you will likely fail. This is where the industry plays its cruelest trick. Modern horticultural breeding has spent decades improving the marigold by removing the very thing that makes it powerful, its scent. Breeders have systematically selected for larger blooms and neutralized the strong, pungent odor to make the plant more appealing to the suburban consumer. When you buy a scentless double bloom hybrid, you are buying a disarmed soldier. You are planting a biological dud that looks pretty but lacks the chemical payload to fight. To execute this blueprint, you must reject the African varieties, Tagetes erecta, often found in big box nurseries, which are bred for show. You need the tactical varieties. Your primary target is Tagetes patula, commonly known as the French marigold. This specific genotype contains the highest concentration of the nematode-killing alpha-terphenyl in its root system. It is smaller, scrappier, and chemically aggressive. If you are dealing with a severe infestation or clearing land, you need the heavy artillery, Tagetes minuta, Mexican marigold. This is less a flower and more of a biological weapon. It grows tall, releases massive amounts of terpenes into the air, and its root exudates are so potent, they are researched as a natural herbicide against bindweed and couchgrass. The calibration test is simple and immediate. When you find a candidate plant, brush the foliage vigorously with your hand. If the scent is faint or sweet, walk away. You are looking for a sharp, pungent, almost musk-like odor that lingers on your skin. That smell is the sound of the plant screaming in the chemical spectrum. It indicates a high load of volatile oils ready to be deployed. Do not compromise on genetics. The effectiveness of this entire protocol rests on the specific molecular machinery of the plant you put in the ground. You are not decorating. You are recruiting an ally. Now that you have secured the correct genetic ammunition, we must address the geometry of deployment. Most attempts at this method fail because the gardener treats the guardian plant as a decorative border, a polite yellow line tracing the edge of the vegetable bed. This is tactically useless. To effectively jam the pest's radar, you must abandon the linear row and think in terms of signal overlap. Imagine your garden not as a painting, but as a coverage map for a cellular network. If the transmission towers, in this case, your marigolds, are placed too far apart, or only on the periphery, you create dead zones in the center of the bed where the protective signal drops and the pests can navigate freely. You need to create a saturation grid. The most effective pattern for this biological firewall is a triangulated lattice. For every 3 target crops, imagine 3 tomato plants arranged in a triangle. You must insert 1 Tagetes patula directly into the geometric center, the centroid of that formation. This creates a 3-to-1 tactical ratio that ensures maximum coverage. When the midday sun heats the volatile oils in the marigold leaves, the column of protective gas rises and spreads laterally. By planting in this tight interlock, the gas columns of adjacent guardians merge, creating constructive interference, a continuous, invisible roof of terpenes that seals off your tomatoes from the open air. This is density warfare. You are consciously sacrificing a small percentage of growing space to secure the survival of the whole. You must suppress the urge to segregate your flowers from your food. You must integrate them until the distinction disappears. In a functional biological system, there are no borders, only overlapping fields of influence. We arrive now at the final precipice, where the question shifts from how to why. What I have handed you is not merely a blueprint for a healthier tomato or a nematode-free soil bed. It is an exit ramp from a broken system. The industrial agricultural complex has spent a century constructing a very convincing illusion. The idea that nature is incompetent, chaos that must be tamed by chemical dominion, and that you are helpless without their bottled solutions. Every time you reach for a synthetic pesticide, you are validating their worldview. You are voting with your wallet for a world where biology is subservient to profit, where the soil is dead dirt, and where your food is an industrial product rather than a living gift. But the moment you plant that marigold next to your crop, not because it looks nice, but because you understand the physics of its root zone and the chemistry of its airspace, you are committing a quiet act of rebellion. You are stepping out of the consumer cycle and into the role of a sovereign creator. You are proving that the most sophisticated technology on Earth doesn't come from a factory. It has been refining itself in the humus of the forest floor for millions of years, waiting for you to remember how to use it. The choice before you is stark. You can continue to treat your garden as a battlefield that requires constant external ammunition, creating a sterilized green desert dependent on the very corporations poisoning the planet. Or you can choose to align yourself with the invisible frequencies of the Earth, using intelligence instead of brute force, and diversity instead of uniformity. The one-plant combo is small, yes. It is humble. But it is a thread that, if pulled, unravels the entire logic of industrial monoculture. The code has been broken. The signal is clear. The question is, do you have the courage to trust the silence of the soil over the noise of the market? The garden is yours to command.